Hi, good evening. Am I audible to you guys? Let me know through the chat if I am audible. Okay, thank you. Yeah, we'll wait for about 5 minutes till others join. I got to know it's raining, is it? It's raining. Some places there is no power. I got to know it is raining in Sri Lanka. So, okay, maybe in the some parts it's raining, maybe. I don't know. Okay, so we'll wait for about 5 minutes and we'll get started. Okay, right. Okay, hi, good evening. I hope everyone are doing great and I hope you all are safe also. So after a long time, I'm back again with the session two. So today we are going to have our physics session two. So if you haven't watched the session one for the physics lesson, so we did only unit two last time. We were only able to do the grade 10 unit 2 last time, and it was like we were discussing about the graphs, we were discussing about how to answer the questions related to that, so on were discussed. Okay, so today you will have the class only till until 11. until 11 you will be having the class, which means we are going to have a complete 2 hour session. But before that, I just wanted to tell you whatever the things I could cover within these 2 hours, we will be able to cover. Because don't worry, I will try to occupy the month of December to give you free theory physics lesson as much as possible. Okay, so I will just give you the lessons, I will help you out, we will have more sessions. So yeah, today I'm starting the part two sessions with the physics, because I didn't have proper time to get done with the biology and chemistry, but I will upload it soon. I will upload the dates and everything soon, inshallah, because I'm under some medication. Because of that, I can't stay late night or I can't have continuous session, but I'm trying my best to give you the best, and we'll see. Okay, right. So last time we completed unit 2, right? Grade 10. So also I wanted to complete the unit 4 and 5, the Newton's law, the frictional force. Maybe you might be finding easy with the lesson. Of course, that is going to be the most important lesson. It's like a couple, okay? So frictional force lesson and also the Newton's law lesson, both of them comes as one set of questions. So where both of these lessons combined together. So let's revise the lesson, and once we complete with the unit 4 and 5, we will go with the unit 11, your physics lesson. Okay, so that's about the turning effect of a force. I'll try my best to complete all your grade 10 physics, yeah, because 60 percentage of your physics lesson will be appearing in your paper, the grade 10 one, and the 40 percentage of your grade 11 physics will be uploaded in your O level paper. So, anyways, let's get started. I hope you are ready and we will move forward. Okay, right. So, as I told you last time, so first I will be explaining you a certain part. Once I'm done with explanation, I will ask you whether you understood or not. At that time, you can say whether you understood or not. Unless that, you have to just focus on the board, right? Okay. So next thing is, okay, you are asking about the recording, right? So the recording is now, say in case maybe due to the rain, maybe due to the connection trouble, or maybe any other reasons you might be leaving the session. It's okay. You can just click the live stream link that I sent in the group back again if you wanted to watch it as a recording. Okay, so that's a tip I'm giving you, because you don't want to wait until I send the recording to you. You can just click the same link to watch the recording. Okay, right. I hope I have answered all your questions. We'll move forward. Let's get started. Okay? Yes. Okay. So today we are going to do with the lesson Newton's law of motion. So we are going to do with the Newton's law of motion. I know you know the lesson very well. Just I'm revising. Your exams are very, very close. Just we can't take the December month. Just think we are only taking the January. Only 1 month left for your exams. So to make your lessons, to make your revising easy, what I'm doing is I am teaching you the lessons. You don't want to touch it again. Okay? So I'm helping you, right? Listen to me. So here in the unit 4 of your grade 10. So here unit 4 of your grade 10, you are studying about the Newton's law, and some people they find difficult in by hearting the three laws. It's okay. It's not a shameful thing. It's okay. I will help you to do that. I will help you to understand. Then you by heart, you understand the situation is better. Okay? Right. Listen. So when it comes to the unit 4, we should know some keywords where we learned in our grade 9. So if I take a object, let's say I have taken an object, and if I'm if I wanted to move this object, what should I do for this object? Either I have to push this object or I have to pull this object. So if I wanted to move an object, I have to either push or a pull. So push or a pull, we call it as what? We call it as force. So who is the scientist to introduce the force? Who is the scientist who discovered force? So that is Isaac Newton. So the scientist Isaac Newton was the scientist to introduce about what? Force. So what do you need to understand? Now say for example, I am pushing this object. So what's the direction of this object? We will say it is towards the east. If I am pulling this object also, it is towards the east. Let's say I'm pushing this way, I am pushing towards the north. So that means if I am doing a push or a pull, or if I am giving a certain force, it goes to a certain direction with a magnitude. So we call that as vector quantity. So remember, force is a vector quantity. They have a certain direction and they have a certain magnitude. So that is, we call it as what? Vector quantity. So remember, force is a vector quantity. So what is the unit you measure the force? What is the unit you measure the force? You measure it by the Newton. So what is the symbol? What is the standard international unit to measure the force? Newton. You indicate it by capital N. You indicate it by capital N, right? So now when we are talking about a movement, let's say for example, now, whenever you wanted to do, let's say if you wanted to move an object. So, whenever you wanted to move an object, you say you need to have a force, right? Is that correct? Is that correct? I'm saying if I wanted to move an object, then I need a force. Okay, you might say it's correct, but I will say it's wrong because to move an object, you need a force. You call that force as what? Resultant force. What do you call that as? You call it as what? Resultant force. So what do you mean by resultant force? Or you can call this as unbalanced force. So resultant force or unbalanced force. So whenever you are having a resultant or an unbalanced force, only that object will be moving. Let's say, for example, you have an object here. Okay, so your friend is giving a force of 10 Newton towards this direction, and you are giving 20 Newton towards this direction. So that means one side, one person is giving the less force, other side, other person is giving the higher force. When there is a difference in forces, when there is a similarity in forces, then we call, now what am I doing? Now you can see the direction of the forces are opposite. So when the direction of the forces are opposite, you will be subtracting those forces and you will say the resultant force is what? It is going to be 10 Newton. So that means who gave the highest force towards this direction? So that means the object move will be moving towards the higher force. So always remember, the object will always move towards the higher force. So that higher force, we call it as what? Resultant force or a unbalanced force. So remember, resultant force or unbalanced force can be identified when there are more than one forces. So whenever there is more than one forces, if it is in the same direction, you do the addition. If it is in the opposite direction, you do the subtraction and you find the final. So that is, we call it as what? Resultant or unbalanced force. So remember, if I wanted to move an object, I need to have a force, not just the force. I need to have a resultant or unbalanced force. So whenever there is a resultant or unbalanced force, only that object will be moving. Did you understand that point? Did you understand that point? Clear with that? So how do we find the resultant force or unbalanced force? So when you have more than one forces, if they are in the same direction, you add them. If they are in the opposite direction, you subtract them. So subtraction or addition of more than one forces, that you call it as what? You call it as resultant or unbalanced force. So remember, an object will be always moving towards what force? Towards the resultant force. Are you clear with that? Yes. Let me know if you are clear. Right, great. Okay, so listen to me carefully. So now what is happening is, now you got to know an object will be always moving towards what? Always it will be moving towards the resultant force. So remember, whenever you talk about the resultant force, the whole Newton's law, the lesson is all about the resultant force. Let me tell you how it is. So before that, it's Azan here. Just give me around 2 minutes. Once the Azan is over, we'll continue. Okay? Right. Okay, thanks for waiting. Let's get started. Right. So your whole Newton's law lesson is based on this resultant or unbalanced force, because this word is very, very important, especially when you are remembering the Newton's first Newton's law, second Newton's law. So these two Newton's law, the law number one, law number two, they are always based on the resultant force. So you have to keep this in your mind. Resultant force means, remember, if there is a resultant force, the object is ready, they are moving. The object will move. If there is no resultant force, remember, if the resultant force is zero, the object is at rest. The object is at rest. So when the object is at rest, remember, the resultant force is zero. So whenever they have the resultant force, the object is moving. Right? So let's come to the first Newton's law, second Newton's law, and third Newton's law. So let me tell you a way to remember. I know your textbook law is little confusing you. Maybe the words they might have used might confuse you, but here remember, always remember, maybe the lesson is short. The shortest lesson has the more things to learn. So you know why? Because in the shortest lesson, they try to get more. They know that you will skip this lesson. That's the reason they try to ask question from you throughout this lesson. So you have to make sure you should know good example for the Newton's law 1, 2, 3, because sometimes they can use the question, they can create a question using the examples of any of the law of Newton. So they can start like that. So because of that only I said you have to know very well about the examples related to the Newton's law 1, 2, and 3. Right? Okay, so listen to me. Now, according to the laws of Newton. So, when you're talking about the laws of Newton, you know that the story of Isaac Newton, right? What happened to the story of Isaac Newton? Actually, he was sleeping under what? He was sleeping under the apple tree. So, while he was sleeping under the apple tree, initially the apple was fixed to the stroke. Listen to me, okay? So, the apple was fixed to the stroke. That is the situation one. Then what was the situation two? The situation two is the apple broke the stroke and fell onto his head. Fell onto his head is the law number two. From the head that the apple bumped down. That means it will hit the head and bump to the floor, to the ground. So that is the law number three. So what is the first law? The first law is the apple is fixed to the tree. Second law, the apple is started coming down. It broke the straw, it came down. Third law is it's hitting his head. The apple hit his head and fell to the ground. So that is the three law. So accordingly, we are going to learn how Isaac understand. How we understood this situation only you are going to learn. Nothing deep, nothing hard. Just understand how I'm going to teach you, right? So now think, I said you the Newton's law 1, right? So when I take the Newton's law 1, initially this apple is fixed to the tree. So was this apple is moving, dear? If I am asking you a question, you have to answer. If I ask you, is this apple is moving? No, this apple is not moving. So I said you right. If the object is not moving, what can you say about the resultant force? The resultant force is zero. The resultant force is zero, which means the object is at rest. So, according to the Newton's law, what is he saying? He is saying the object is at rest. He's saying what? He's saying the object is at rest. Now think about the situation in during the Aurudu season. You and your friend is playing tug rope. When you and your friend is playing tug rope, when both of you give the same forces from the opposite side, so here also 50 Newton, here also 50 Newton. When both of you give the same forces from the opposite side, what will happen to the forces? The forces will be cancelled off, which means the resultant force will become zero. So that is what you have to understand. So I am asking you a question. Let's say if the apple is fixed to the stroke from the center of the apple, what is the force that is acting towards the center of the earth? What is that force that is acting towards the center of the earth? Right. So that is we call it as what? Weight. So can you remember when you were studying? Now this is we are doing a revision, right? Can you remember when you was learning grade 10? When you was in grade 10 or maybe you learned this lesson already. Can you remember that? We learned that if an object is hung, okay? If an object is hung, from the center of that object, they will be always having a force weight, and if that object is at rest, the opposite to the weight for the string of that object, they will be having a opposite force. We call that as what? Tension. So which means according to the first law of Newton, he says that object is what? At rest. Why? You have two opposite forces acting on this apple. One is a downward force, that is a weight. Another one is the upward force, that is we call it as what? Tension. So if this is also 50, this one is also 50, what will happen? The resultant force will be what? It will be zero. So you have to understand You have to understand clearly. What do you need to understand? According to the Newton's first law, what is he saying? Now say me, what is the first law? Say it with me, okay? Now now do you have unbalanced force in the first Newton's law? Do you have unbalanced force? No. So that means how we can write the first Newton's law? We can write until an unbalanced force. So until an unbalanced force acting. Now, why did I say the word until? What was the reason I said until? What's the reason? Until means, do you have the unbalanced force now? No. Until you get it. Still, what can we say? Until an unbalanced force acting on an object. So, until an unbalanced force acting on an object. Now, what is happening to the apple? Is this apple is moving? No, the apple is at rest. So we can write it until an unbalanced force acting on an object. The object, you put a comma, the object remains stationary, or you can write the object is at rest. Just write it in your own words. You don't want to by heart the exact word. You can just write what you understand without changing the meaning. Did you understand? So until an unbalanced force acting on an object, the object at rest, or we can say the object will remain stationary. The object will remain stationary. So this is not the complete Newton's law. We are just understood a part of the Newton's law. So shall we go to the next part of that? So when it comes to the first Newton's law, you have to by heart, you have to understand the whole Newton's law. A part of that we just understood. Are you clear with that? A part of that we understood. Any doubts in that? Any doubts in that? Yes, right. Okay, I'll explain you one more time. Listen to me, get an idea. Unbalanced force in the sense you can call it as external force also. The force that is more than something that is able to move. That is, we call it as unbalanced force. So listen to me again. Just focus. Now, what is Newton's first law? Think the situation. Think about the situation. What happened? Isaac was sleeping under the apple tree. So the first incident was apple was at rest. So why was the apple rest? The apple was rest because there was no force. What force? What is the force that will help you to move? Unbalanced force. So what is our first Newton's law? Until an unbalanced force acting on an object, what will happen to the object? The object will remain stationary. Did you understand? Did you understand? Clear with that? Got the idea? So he said, if the object didn't get any forces, it will be at stationary. So that's the situation that you have been written here. Clear? Got the idea? Now after this, there will be a comma. We have to continue with the other part of the Newton's law. Before that, I have to explain you. Before that, I will explain you how that Newton's law will be coming. Okay? Right. Listen to me. Okay? You have to keep this in your mind. Let me erase the board and then we'll go to the other part. So listen to me. Let me take you the normal life examples, which means like everyone has gone experience in the bus. Are you all? Have your experience in the bus? It's better if you have experience in the bus. That will be nice. I can explain you easy. Say for example, now the bus is stop. Okay, now this is the bus stop. This is the bus stop. So in the bus stop, the bus is already stopped. That means the bus is at rest. The bus is at rest. Now what are you doing? You are entering inside the bus and you are standing inside the bus which is at rest. Listen again. You are standing inside the bus which is at rest. Now do you have any force acting in the bus? No. You don't have any force that is acting in the bus. Now let's say now the bus is starting to move. It's starting to move. Let's say the bus will move at this direction. The bus will move at a particular direction, and this is going to be the direction of the force. Now tell me, which part of your body is in contact with the bus? Which part of your body is in contact with the bus? Is it your leg or is it your head? It's your leg. So that means your leg is in contact with the bus. So if the bus is moving in this direction, means your body also moving in the same direction, right? That means your leg will be taking to that direction, isn't it? So you will have the same direction. So now what is happening is, let's say for example, you are standing here, right? And in front of you, let's say some people pulling your legs. Just think, in front of you, some people pulling your legs. In which direction will you move? Let's say if people comes like this, they are trying to pull your legs this side, what will you do? You will go back, right? You will go back. People in front of you, if they try to pull your leg, just to imagine, if they try to pull your leg, what you will do? You will move back. You will move back. So just keep this again in your mind and just think, now you are big. You are mature enough. You don't hold the bar. You don't hold the seat. You just stand in the bus. Suddenly, the bus starts to move. In which direction will you move? Will you move forward or will you move backward? Has anyone got this like, have you ever got this what do you say, experience? You stand, suddenly the bus is started. What will happen to your body? You will go backward. So understand what's happening. You will go backward. Your body will what? Your body will fall back. You have to understand this according to the first Newton's law. So now, according to the first Newton's law, what happened? You didn't have any unbalanced force acting on an object. So now what happened? Just think, in the bus, you was just standing, there was no force. Once the force was given, what happened? Your body started to work according to the bus movement. So now what is happening now? Already the bus has got the force. Now bus is already moving. You are steady at the same direction. Now say for example, now you are moving in the bus. Already the bus is moving towards the bus stop, let's say. Now suddenly your friend came in front of the bus. Now what will happen? The bus driver, he will stop the bus by applying what? The brake. So if he apply the brake, what will happen? Now you are not holding the seat, you are not holding the bar or whatever it is, you're not holding anything, you're just steady there. But suddenly your friend came in front of the bus driver applied the brake. Now what happened? What will happen? Now usually this is the direction that the what do you say, the tire will be moving, right? So if you apply the brake, towards which direction will be the tire will be pulled? It will be pulled towards the opposite direction. So when they pull towards the opposite direction, what will happen? Let's say if the bus is moving at the 50 Newton towards this side, if I want to make the bus to stop, to make it rest, I also have to apply a brake of what? 50 Newton. So what will happen? Now what will happen? Once you apply the brake, your bottom part of your body, it will come to rest. What will happen to your head? It will keep on falling front. Have you ever experienced, you will try to go front, you will keep on moving without control. So that means what is happening? You are uniformly moving. So you need to understand. Now think, you're going to play carom. I'll ask you, you're going to play carom. Now you have the disc. When you don't hit the disc, do you have an unbalanced force? No. So we say until an unbalanced force acting on an object. the object is at stationary. The object will remain stationary. So that means this object is at rest. So once you give a force, what will happen? This disk will smoothly, it will move. We say uniformly. So it will move with what? Uniform velocity. It will move with what? Uniform velocity. So this is what you call it as the first Newton's law. So that's what, according to the first Newton's law, they say that you are wearing seat belt. Why are you wearing seat belt? Because when they apply brake, you might move forward accordingly, uniform velocity. According to the uniform velocity, you might move forward. So that's the reason you are wearing what? Seat belt. So according to first Newton's law, what is the first Newton's law? Until an unbalanced force is acting on an object, the object will remain stationary. And if there is the motion, we'll say, if there is the motion, it will move with what? It will move with the uniform velocity. So that's the first law of Newton. Did you understand? Clear with that? So that's the first law of Newton. So you can take the example bus. You are moving in a bus is example. You can take playing carom is an example. You can take the example wearing seat belt to prevent accidents is an example for the Newton's first law. Are you clear with that? Are you clear with that? Got the idea? Do you want to exactly by heart the words? No. You can write it in your own way if you understand the situation clearly. Are you clear with that? Yes? Got the idea? Understood? Clear with that? Before we go to the second law, so what are the example we can take? I said you the example moving in the bus, applying brake while in the bus. They will use that example which is already in your textbook. Wearing seat belt to prevent accident. This is related to the Newton's first law. Playing carom is first Newton's first law. So you can take those example as the Newton's first law. So in the Newton's first law, think until, the word they use is until an unbalanced force. Okay, let's come to the Newton's second law. So we are going to go with what? Newton's second law. So when it comes to the Newton's second law, it's easy. Okay, so Newton's second law is easy, but still I have to tell you, okay? So you know that your Unit 2 lesson is grade 10 is there, right? That will be combined with your Unit 4 and Unit 5. So this is like a combination, okay? These lessons always they combine. If you know these lessons are getting combined, you have to be very aware about it because the lesson velocity comes in this lesson, right? So you have to remember the velocity is also used here. In this part, they are using the velocity. So here in the Unit 5, they are using the force. So again, you learn the force in Unit 4. So Unit 2, Unit 4, Unit 5, they are all combined as one question set in your paper. So you have to remember that. Right. Okay. So according to the Newton's second law, what's the situation I said? You had the apple tree. So what happened? Now the apple has broke the stroke. Now once the apple broke the stroke, the first question I'm asking you, will you have the tension? Will you have the tension? So if it is hung, you will have the tension. If it is not hung, will you have the tension? No. So that means when you don't have the tension, what is the only force that will be acting towards what? That is towards the center of the earth. The only force that will be acting towards the center of the earth will be gravitational force. As you say, we can take the weight. We can take the weight. We can take it as a gravitational force. We can take either one of them. Now what happened? Initially, according to the Newton's first law, did you have resultant force? Did you have resultant force? No, you didn't have resultant force. According to the Newton's second law, what happened? Initially, the tension was 50 Newton, weight is 50 Newton initially, startingly. So that means the resultant force was zero. Now what happened? It broke the stroke. There is no tension. The only force that you have is 50 Newton. So which means what is the resultant force here? The resultant force, which was zero, it has become 50 Newton. So what happened? So when there is a resultant force, there will be a movement. So you know that when there is a resultant force, there will be a movement, right? There will be a movement. Now what will happen? Can you remember? Unit 2, I said you, unit 2 will be combined whenever I'm explaining you the unit 4. Can you remember I explained you about the ball? When you throw the ball against the gravity, when you throw the ball against the gravity, what will happen to the velocity? Velocity will be decreasing. Whenever the ball is coming towards the earth, when something is coming towards the earth, we have to understand the velocity will be increasing. So what will happen? While the apple is coming down to the ground, they will have a velocity. What will happen? They will be having the velocity. Is that the normal velocity they are having? No. What is happening to the velocity? Velocity is increasing. So when the velocity is increasing, can you remember I said you a term? So when the velocity increases, we call that as acceleration. So what do we call it as? We call it as acceleration. Now you know that when you take the equation for the weight, what is the main factor that is connected with the weight? What is the main factor that is connected with the weight? Mass into gravitational force. Let's forget about the gravitational force. When you take the mass, now look here, your Newton's second law is created by the mass and the acceleration. So what you need to understand, now in the Newton's second law, you are having the unbalanced force. So how do we start the word? How do we start the Newton's second law? We say, when. We use the word what? When. In the Newton's first law, what did we use? We use the word until. So we use the word what? We use the word until. So in the first law, we use the word until. In the second law, we are using the word when. So that is the difference. When an unbalanced force acting on an object, acceleration directly proportional to the force and inversely proportional to the mass. So that's the Newton's second law. Are you clear with that? Are you clear with that? Are you clear with that? You know why? I could have skipped this lesson. I would have said, like, you can just read it out and understand. No, this lesson is important because you get questions out of this lesson. We call this as proportional symbol. You have learned in maths proportional. You will know this. Right, look here. So, what is the Newton's second law? Newton's second law, it speaks about the acceleration. It speaks about what? Mass. So how we can say, when an unbalanced force acting on an object, acceleration directly proportional to the force, inversely proportional to the mass. So that's the second law. If you just remember this equation, you don't want to by heart. You just understand. That's it. Look at the word until. When? Whom are we talking about? We are talking about the unbalanced force. So that is what we need. Did you understand? Right. Look here. So what I want to tell you is, if you wanted to remove this proportional sign, if you wanted to remove this proportional sign, you have to add this constant. You have to add a constant. You don't want to know about it, but just I'm saying you, if you want to remove this proportional sign, you will be adding a constant letter. You will be adding a constant letter. So what will happen once you add the constant letter instead of this proportional sign? That proportional sign will turn as equal sign like this. So what you will do, if you want to make the force as a, if you want to make the force as a subject, Have you studied formula in maths? If you want to make the force as a subject, what you will do? You will take the division mass to the other side. So if you take the division mass to the other side, it will come as what? Multiplication. So that means what's the equation to identify the force? Force is equals to mass into acceleration. Mass into acceleration. So this is the equation that you will identify the force. Clear? Got it? So in this lesson, what's the equation that you're learning? The first equation that you are learning in this lesson in the Newton's second law. So in the Newton's second law, if they give you any examples related to the acceleration, or if they use the word increasing velocity, or if they even say you mass, if they speak about mass, acceleration, increasing velocity, then understand that question is related to Newton's second law. So according to the Newton's second law, you identify the equation force is equals to mass into gravitational force, sorry, mass into acceleration. So what is the unit you measure? What is the unit you measure the force? The standard international unit you measure the force is Newton, but you can also use this what? Kilogram meters per square. You can use this also, but I will recommend you to use this one. Got it? Okay, so what is Newton's second law? So Newton's second law is the time when the apple broke the stroke. So when the apple broke the stroke, there was no tension. What happened to the apple? Apple had only the weight, which means they had only one force towards the ground, where they had the resultant force of 50 Newton. So what is happening when something comes towards the earth? Whenever an object comes towards the earth, you will have the velocity. What will happen to the velocity? Whenever it comes towards the earth, the velocity will increase. If the velocity increases, there will be an acceleration. So I said we are talking about the weight. You have the weight. Why do you have a weight? Because there is a mass. So which means the Newton's second law is about what? It is about the combination of acceleration and mass together. So which means what is our Newton's second law? When an unbalanced force acting on an object. So look at the word when. When means you already have given the force. When an unbalanced force acting on an object, what can you say? Acceleration directly proportional to the force, inversely proportional to the mass. You remember as this is as a equation that will make you to remember the Newton's second law. Sometimes what I'm teaching you might be helpful for your third term also. So you can also give a try. So shall we go to the Newton's third law? Yes, everyone knows the Newton's third law. You don't need to by heart this definition. That's what I said you, right? If you're by hearting, that's what do you say? It's crazy if you're by hearting. Don't by heart. You have to understand. Clear with that? I already repeated the Newton's second law, I guess. Just when an unbalanced force acting on an object, acceleration directly proportional to the force, inversely proportional to the mass. That's it. That's the second law. Okay? Right. Let's go to the Newton's third law. So when it comes to Newton's third law, so you have to understand the situation like this. I know you will say every action as equal and opposite reaction. Okay, yes, you already know that. But still, there's something you have to remember. Okay? Right. Look here. Now, according to the Newton's third law, you can remember this one. Okay, now say for example, you have a table and this is your knuckles. Okay, this is your knuckles in your hand. You have the knuckles. So what are you doing? You are punching. You are punching the table with 50 Newton. Now, just think when you punch the table with the 50 Newton, why is your knuckle is becoming red? Why it's becoming red? You just hit the table, right? You should think, right? You just hit the table. But why did it become red color? it's like this. When you hit something with the 50 Newton, let's say if you hit something with a certain force, that object also will give that the same force back to you. If you hit very fast, the same force that you hit will come back to you. So that means this will be your action, that your hand is becoming red will be your reaction. So, according to the Newton's third law, every action has equal and opposite reaction. It can be the rocket flying, so rocket will fly. So the action is what? They push the ground. Going up is the reaction. Then they can give you examples related to the balloon that is flying. So you can understand clearly that action and reaction matters a lot in the Newton's third law. So you don't want to by heart the Newton's third law. You are really good in the Newton's third law. So let me give you some sample of question that is related to the Newton's second law. Let's see whether you are able to do such question. We'll see. Okay. Let me give you a question. Let's see whether you can do it. I'm just giving you on spot. You also do it on spot. Just let me know. Okay, let's say an object. I'm just checking whether you can do it. Okay, any questions? That is combination of unit 2 and unit 4. Okay, an object of 5 kilogram is pushed in both sides as shown in the diagram. Let's say I have given a diagram to you. Let's say find the acceleration of this object. Can you find the acceleration of this object? Yes. Can you find it and let me know? Okay, I'm seeing all your answers, okay? I'm asking the acceleration, huh? You have to find the acceleration. Give me the final answer. That's what I'm just checking in case if you get any questions like this in your paper. It can be in your MCQ, especially not in your essay type question. They don't ask small questions like this. They can ask you in your MCQ. So I'm just checking whether you can do something like this. Okay, we'll see. The unit for the acceleration is meters per square. You should know the unit, huh? If you know the unit, you can get the marks. If you don't mention the unit, you don't get the marks, huh? Okay, right. I will tell you the answer. Look here, first, what is our equation? Okay, so first you need to understand what are the things that is given in our question. Okay, so they have given the mass. They have given the mass for us. Okay, and they have given us to find the resultant force since it's in opposite direction. Our resultant force is 80 Newton. Our resultant force is 80 Newton. So to find the acceleration, we have two. We have two equations to find the acceleration. What is the first equation? Acceleration equals to final velocity minus initial velocity divided by time. Another equation is force is equals to mass into acceleration. Out of this, which equation will you select to find the acceleration? Have they given you the velocity here? So if they haven't given you velocity, you can use this one. So you have to use the second one. How will you use it? You will write the force is 80, mass is 5, into acceleration. Take the 5 to the other side. The multiplication comes as a division, which means your answer has to be 16 meters per square. So if you have got the answer as 16 meters per square, that is correct. So that's how you answer. Did you understand? How I got 80? Look here. 120. Opposite direction. I have to find the final force, resultant force, which 80. 100 minus 20, 80 Newton. Okay, I will give you a final question, some similar to this. Let's see, this time you're not going to miss the target, okay? Right, let's see if you can find it something like that. Okay, let me give you, just give you something that will make it benefit for you. I'm just writing it out. Okay, so let's say, for example, let's say an object moved at a velocity of 15 meters per second. Okay, in 5 seconds. In bracket, mass of the object is given. Let's give it like this. Okay, find the force. Can you find the force? And let me know. These all comes for your MCQ. Nothing comes to your essay type. So you have to know it. Don't take much time to answer, okay? Because this is something that you have to take around 1.5 minutes. Because for your MCQs, you have to just take 1.5 minutes. You don't need options. You can just do it and find the answers. That's it. Right. We'll do it together. Look here. So look here, they have given you the velocity. They just said it's moved at a velocity. So what's the equation to find the acceleration? First, you have to find the acceleration. Final velocity minus initial velocity divided by the time. So what's the final velocity? What's the final velocity? If they haven't said you, an object moved from the rest. They didn't say initially. They didn't use the word initial. They didn't say the object moved from the rest. So whenever they use the word the rest, if they use the word initially, then remember that's going to be the starting velocity. If they just said the object moved at a velocity, that means the velocity is the final velocity is 50. So how are you going to find? So this is going to be the 5 seconds, which means it's going to be 3 meters per square. So that means what's the equation to find the force? Mass into acceleration. So what's the mass? 2 multiplied by 3. The answer is 6 Newton. So if you have got the answer by 6 Newton, that's correct. So this is how you do it. They don't always ask you questions that is very easy. They can ask you the questions that can connect with your unit 2, that can connect with your unit 4. They can. So always you have to expect which is not expected. Got it? Right. Okay, now let's go to the next part of your lesson, which is momentum. So momentum part is very easy. Momentum part is very easy. I want to say you momentum means how difficult to stop and moving object, that you call it as momentum. So momentum is like you say you have a real car, you have a toy car. Which car is hard to stop? the real car. So that means momentum is something you're measuring, you are understanding how difficult to stop the moving object, that you call it as momentum. So when you talk about momentum is depending on how many factors. It depends on what? Momentum depends on velocity. It depends on velocity. And the equation comes what? It comes with the mass into velocity. So mass into velocity is the equation for the momentum. Also the factors that is affecting the momentum. So one is mass, one is speed. Another name for the speed is velocity. So when the mass and the velocity is together, that we call it as momentum. What's the unit you measure them? Kilogram meters per second. Don't confuse with the kilogram meters per square. So kilogram meters per square is the unit you measure for the force. Kilogram meters per second is the unit you measure for the momentum, because velocity you measure by meters per second. Velocity you measure it by meters per second. Acceleration you measure it by meters per square. So you have to remember this 1 and 2. Some people they do this silly mistakes. So just remember it. Clear with that? Got the idea? Understood? Right. Okay. So there's another part in this lesson, especially about the moon. So they will ask you to think that you are an astronaut, you will go to the moon, what will be the weight in the moon, how it is. Sometimes you might have got this question when you was doing your first term in your grade 10, second term or third term in your grade 10, I'm not sure. But at least once in a lifetime, you might have faced a question related to this. So I will definitely tell you how to answer this question. Okay. Right. Now you know that the earth is a sphere, right? It is a sphere. So imagine this earth is like a ball. So when it is a ball, now what is it happening? Now, whatever the object in the earth, what is it happening? It is pulled towards the center of the earth. Everything is pulled towards the center of the earth. We call it as what? Gravitational force. So this gravitational force, in another term, we call it as what? We call it as weight. So most of the time, what's the equation for the weight? Mass into gravitational force is the equation for the weight. So I'll ask one question from you. So the question is, now we said the gravitational force, weight, they both are equal, which means what is the most suitable unit that you can measure the weight? Remember, that's Newton. You measure the weight by Newton. You measure the mass by what? Kilogram. Now come to the moon. Now you have heard that Neil Armstrong, right? The Neil Armstrong, the one who went to the moon for the first time. So you may have heard about him. So now, what happened to the Neil Armstrong was he kept his foot on the moon, or first he was flying. So, what happened in the moon? Can the astronaut keep their leg? Can they keep their foot? Do they just like walk like us in the earth, like in the moon? No, they float in the moon. So when they float in the moon, like you have to think, like what do you say? Now, in the earth, we are just stepping our legs in the moon, but when we are stepping our legs in the earth while we go to the moon, we are just floating. What can be the reason? What's the reason? Is it because of our body weight? Is it because of our body weight? Let's say yesterday, my body mass, let's say my body mass is 60 kilogram. Let's say it's 60 kilogram. If my body mass is 60 kilogram, when I go, now you know that weight is depending on mass and gravitational force. So we have to understand, why are we floating? Why are we flying on the moon? So you have to understand. So my body weight, let's say my body mass is 60 kilogram. When I'm going to the moon tomorrow, let's say I'm going to the moon tomorrow and I'm in the moon right now. So now I'm flying. Do you think that my body mass changes within a 1 day? Does my body mass changes within 1 day? Does it change? No. So that means what is the factor that will never change? When you go to the moon, when you go to the Mars or Jupiter, Saturn, wherever you go, my mass will never change. So who is the one who is changing here? If I am floating, what's changing? Gravity. In the earth, the gravity is high. In the moon, the gravity is less. So when the gravity is high, you stand. When the gravity is less, you float. So the reason that you are floating in the moon is the only reason that you are having the least gravity in the moon. So they can ask in the exam, the very common question they can ask is, let's say, now your body mass is 60 kilogram right now on in the earth. What is your body weight? What is your body weight in the earth? 60 multiplied by the gravitational force, approximately we take it 10, which means my body weight is 600 Newton in the earth. It's in the earth. Now, once I go to the moon, what will be my body weight in the moon? So that means, according to the science, they say the gravitational force is 1/6 of the earth in the moon itself, which means 1/6 of the earth in the moon. So which means I can take this 1/6 multiply by 600 of my body weight in the earth. So in the moon, what will be my body weight? My body weight will be 100 Newton. So in the earth, I'm 600. In the moon, I'm 100. That's what I'm flying. What is the reason I'm flying? All because of the gravity. Are you clear with that? Are you clear with that? Most of the time they will give you a question with 660 like that, so you don't want to worry about it. Every year you get the easiest simplification. Sometimes you can also get decimal, but it's very rare. Are you clear with that? Are you clear with that? Yes? Any doubts? Any doubts? Right. Someone asked me a question, but I missed it, but I don't know who was that. Give me a minute. I'll just see if anyone I missed. Okay, I guess I didn't miss anyone. If I miss, you can resend the message to me back again. So, do we think our weight is our mass, but in reality, our body weight is without gravitational force? This is what you have to understand. Now, our body weight is there, right? Our body weight is depending on two things. One is by the mass. What you have to understand, wherever you go, your mass will never change. So, if you go from one planet to another planet, the only thing that will be changed is what? The gravitational force. So, why are you floating in the moon? The gravitational force. So, the gravitational force is the reason that you are flying, not because of your body mass. Are you clear with that? So, your body weight can change. That means your body weight can change because of the gravity, not because of your mass. Your mass is fixed. Are you clear with that, Abdulahad? Right. Okay, so you are clear with that, and we are done with that lesson also. So I hope you understood the lesson clearly. Do you want to revise it back again before your exams? No need. If you're really good in that, you have to understand. Yes, force and the weight both are equal. Now let's come to the frictional force. Okay, in the frictional force, there is a graph. I don't know how many of you all know about the graph. Maybe many of you all know about the graph, but there is a graph. Sometimes I remember 2018 paper, you got a graph to mark. Okay, 2018 paper, 2022 paper, you got a graph to mark. So this time 2025, sometimes you can get this graph because this graph has appeared in 2 3 years back again. So that means you have to remember there is high chance you can get anything which is not appeared in last year paper. So let's study about the frictional force. So did you understand why am I focusing on this lesson? Yeah. Okay, let's move. So let's come to the frictional force. So when it comes to the frictional force, I will say you very interesting part of this lesson. Now say frictional force. Now what is this you have to understand? Under the lesson frictional force, remember unit 4 is combined. Unit 4 has been combined. So under the lesson frictional force, unit 4 has been connected. So you have to think unit 4 will always come. Newton's law, everything will be there. Newton's law you have to remember, especially Newton's law will be connected here. Okay, right. So listen to me. So when it comes to the frictional force, in which direction? Now say for example, you have an object. This object is moving in this direction. If this object is moving in this direction means the motion, let's say if you are normally moving in a particular direction, we call this as relative motion. We call these as what? Relative motion. So that means you are having contact with the ground and you are okay to move in that particular surface. That is, we call it as what? Relative motion. So that means your feet is relative to the surface of the object and you can move in this particular direction. So that is, we call it as what? Relative motion. So what is frictional force? So frictional force means a force which oppose a relative motion. Oppose a relative motion means, what do you mean by oppose? Opposite. So if a force that comes opposite to the relative motion, so this side is the relative motion, that means frictional force will come opposite to the relative motion. So if you have a force that comes opposite to the relative motion, that you call it as the frictional force. So what do you mean by frictional force? Frictional force means what? A force which opposes the relative motion of an object when two surfaces is in contact with each other. So what is the situation that you get the frictional force? The frictional force will be appearing when you have the contact with the surface. What do you need to understand? So when you have the contact with the surface, at that time you are getting the frictional force. So remember, frictional force will be always created whenever two objects are in contact with each other. So you have to understand that clearly. So frictional force is like an enemy. Just think, you are moving in this direction, someone is not letting you to move to the other direction. So that is, we call it as what? The frictional force. So always remember, frictional force, when does it get created? Whenever, when two surfaces is in contact with each other. So if they're in contact with each other, you have a frictional force. When they are not in contact with each other, will they have a frictional force? No, they will not have the frictional force. So I have to ask you a question. So listen to me. Now I know you have studied about the frictional force when you was in grade 10. Also, maybe you are a grade 10 student. You might have studied in your first term and everything. So listen to me carefully. So when you take the frictional force, you can divide the frictional force into three parts. One, we call it as the static frictional force. Other one, we call it as the limiting frictional force. And the next one, we call it as the dynamic frictional force. So what are the three types of frictional force you have? Static, limiting, and the dynamic. So you have heard static posture, dynamic posture. So whenever we say the word static, you have to remember you are not moving. So remember, when you are not moving, according to the unit 4, I said, will you have a resultant force? No. So that means in the static frictional force, you will not have a movement. That means when you don't have a movement, remember you will not have a relative motion. So there will be no relative motion, there will be no resultant force, there will be no movement. So the situation where the object doesn't move, even though the object is in contact with the surface, that situation we call it as the static frictional force. Let's forget about the limiting. Come to the dynamic. Dynamic is opposite of what? Static. So dynamic frictional force, dynamic means it's moving. What do they have? They have a resultant force. And also, what can you say? They do have a relative motion. So that means limiting frictional force is between not moving, between moving, between the moving and not moving only. We call it as what? The limiting frictional force. So we have to study about the static frictional force. We have to study about what? Dynamic frictional force in detail along with the limiting frictional force. Are you clear with these ideas? Are you clear with the idea? Yes? Are you clear with the idea? You got it? Yes? So, what didn't you understand? What didn't you understand? You didn't understand what? Okay, right. So I'll just tell you, you have three types of frictional force. One is static frictional force, limiting frictional force, dynamic. Static in the sense not moving, where you don't have a resultant force, you don't have a relative motion, which means this object, even though it's in contact with the surface, they don't move. Dynamic is opposite to the static. So they can move. They have a resultant force. They have a relative motion, that is dynamic frictional force. So the frictional force that is between the moving and not moving, that you call it as the limiting frictional force. So listen to me. Now what is happening is I am going to explain you about the static frictional force. I will connect with the limiting. I will connect with the dynamic. You have to listen to me because this is important. Okay, you should not get confused. And also remember the Newton's law also will be connected. So you have to listen to me. I don't know whether you learn by connecting with the Newton's law, but you have to listen. So listen to me carefully. Now say for example, you have a car. You have a car here. And this car is in contact with the road. This car is in contact with the road. So remember, whenever an object is in contact with any other surface, they will be having a frictional force. Say this road is having a frictional force. Okay, imagine this road is having a frictional force. So that means you have to understand. Now, say for example, this is you and this is your enemy. So let's say you are the relative motion and your friend is the frictional force. Okay, sorry, not your friend, your enemy is your frictional force. So if your enemy is hitting you hard, you also should hit him harder than him, right? So then only you will win. Same like that, if you wanted to move, if you wanted to pass the frictional force, always remember the force that you are applying, we call it as the applied force. The force that you are applying, we call it as what? Applied force. So that applied force has to be more than the frictional force if an object has to move. So remember, what is the condition? If an object has to move, the object should give the applied force more than the frictional force. So now you have a car. This car is having a contact with the road, and this road is having a friction. So what do you need to understand? This car is having a friction. The friction in the surface is 50 Newton. the friction in the surface is what? 50 Newton. Now, have you ever tried to push the car? Has anyone tried to push the car? Okay. So if you have tried to push the car, you might have experience. Later, if you wanted to push the car, you can just give a try and push the car, but not harder. Just try to push the car until it slightly move. Okay. Right. Listen to me carefully. Now, let's say if I am pushing the car, let's say I am pushing the car with 10 Newton. So the force that I'm applied here is 10. The frictional force in the road is 50 Newton. Do you think my object will move? Do you think my car will move? Do you think my car will move? Yeah. Do you think my car will move? No. Okay. Right. Listen. Now, what is happening when I move the car will slowly go front and it will come back to the exact position. Has anyone got this experience? You move the car front, it will go front and it will come back to the exact position. So that means if you move the car with the 10 Newton, it will come back with the 10 Newton. Why? Because your applied force is not more than the frictional force. So accordingly, can you tell me which law of Newton is this? You give an action here, reaction is 10 here. According to which law of motion is working? According to the Newton's third law. So according to the Newton's third law, if you push the car which is less than the frictional force, it will come back to the exact position with the same force that you applied. So here see both opposite direction, 10, 10. You subtract, the resultant force is equals to 0. So will this car will move? Will this car move? No, the car will not move. So when the car doesn't move, we call this situation as what? The static frictional force. We call this as what? The static frictional force. So the static frictional force means the object, the situation where the object doesn't move. That means what you need to understand. Your applied force is less than the frictional force. So this is the situation. Clear? Got the idea? Understood? Got the idea? Any doubts in that? Right. Okay. Look here. So now what is happening is, now what am I doing? I'm calling my friend. Let's say around 3 people, around 3, 4 people. What happened? Now I'm calling, let's say 4 people. I'm calling 4 people. Each people, they are pushing with 10 Newton. So each people, they are pushing with 10 Newton. So now what is happening is, let's say I'm calling another brother also, but he's just giving me a small push, like around 0.1 Newton. Rest of them are giving me what? They are giving me 10 Newton. So what is happening to my force right now? The force that I'm giving to the car right now is what? 50.1 Newton. I have given 50.1 Newton. And my frictional force is 50 Newton. So you can see that a point, a small point only increase. That means a small point is there. That means, say, if I wanted to make the car to move, it has to be at least 51 Newton. Then only it can move. Because always remember, if the frictional force, that means if the applied force is more than the frictional force, solid way, then definitely it will be moving. But here it's just by point. That means it's about to move. It's not moving. It's about to move. This situation, we call it as limiting frictional force. So limiting frictional force means we say on the verge of the motion. So on the verge of the motion in the sense that particular object is about to move, but is it moving? Let's say if someone gives another force, let's say if someone gives 1 Newton, you are getting 51. Then that object is about to move. But are you moving the object? No. The situation where the object is about to move, that situation, we call it as the limiting frictional force. Now look at the difference. Initially, I had given 10 Newton. Now when I compare 10 to the 50.1 Newton, what's the difference? What is the difference? 10 to the 50.1 Newton. What's the difference? It's 40.1 Newton. So that means you can see that here you have applied 10 Newton. Here you have applied 40.1 Newton. So that means you have to understand limiting frictional force is the highest frictional force. So which point is the highest frictional force? Which type of frictional force is the highest frictional force? That is limiting frictional force. Now think about the dynamic. Let's say if I ask a person to come and give me 1 Newton, what will happen? It will be 51, right? It will be 51 Newton. So that means in the limiting frictional force, I had 50. And here in the dynamic frictional force, I had 51. So what's the difference between the 50 and the 1? 1 Newton. So that means who has given the highest force? Which part of the frictional force has the highest force? The limiting frictional force. So that's the reason we call the limiting frictional force as the highest frictional force. So you have to understand, because we will be learn to draw the graph. So when we learn to draw the graph, you need to understand that the highest frictional force will be taken by the limiting frictional force. Dynamic frictional force, even though they have a small force, more than the frictional force, they will keep moving. That is what you had to understand. Any doubt? Any doubt before we go to the graph? Before we go to the graph, any doubt? So just understand, static frictional force means the object is not moving while the applied force is less than the frictional force. When it comes to the limiting frictional force, applied force is higher. Yes, applied force is higher than the frictional force. Is it completely small? A small amount is higher. It's about to move. If you give a little amount of force more, it's about to move. But is it moving? No. But if you come to this one, the dynamic frictional force, you have given a solid one frictional force to keep the object moving. So which means here applied force is greater than the frictional force. That's what it's moving. But when you compare every frictional force, who has the highest frictional force? Limiting frictional force. Sometimes you can get this in your MCQ. Right. Now listen to me. Now we have to learn to draw the graph. So drawing, like, what do you say? Drawing the graph is not a big deal, okay? So drawing the graph is not a big deal. I will say you like, what do you say? Let me tell you how this graph is working, okay? Let me tell you how the graph is working. Most of the time, they will not ask you to draw the graph, but they can ask you to mark the graph. They can give you a graph and they can ask you to mark the graph. So to mark the graph, let's say for example, they have given a graph like this to you. They have given a graph. So they have given the frictional force in the y-axis. They have given frictional force in the y-axis, and they have given the applied force in the x-axis. Okay, applied force in the x-axis. So let's say the maximum frictional force is 40 Newton. The maximum frictional force is 40 Newton. Okay, so they will give you something like this. Right, they will give you something like this, and they will just give you something 10, 20, 30, 40, and somewhere here, and let's say they have given you 50. Okay, so you have to know that they have given you something like this in your paper. So they have given you something like this in your paper. Okay. And they will ask you to mark the three forces according to the paper. Now, can you see according to the Newton's law? Can you remember now what is the maximum frictional force? 40. Now, before that, if you hit 10, it will come back with the 10. If you hit 20, it will come back with the 20. If you hit with the 30, it will come back with the 30. 40, 40. Still, the resultant force will be what? The resultant force will be 0. So, this straight line indicates that they are 0. They are not moving. They are just there. They are just uniform. They are just there. So, that means what kind of frictional force is there? What kind of frictional force is indicated by this side of the graph? What kind of frictional force? Very good. So how do you mark it? In your paper, how do you mark it? You have to put the curly bracket. From here to this point, it's static frictional force. Did you understand? Now what is happening to this point? Can you remember who has the highest frictional force? Who has the highest frictional force? Who was that? The limiting frictional force. So the point is indicating the limiting frictional force. Then this one, who is going in the straight line, who is moving in the uniform velocity, once the object started to move, do they want to care about the forces? No, object is moving with the uniform velocity. So this is going to be the dynamic frictional force. So this is how you are marking. Are you clear with the marking? Yes. So this is how you are supposed to mark the graph. Every year you get graph like this. Sometimes the values can be changed, but the graph is always like this. Clear? Got it? Sometimes they will give you half graph. Sometimes they will give you the complete graph I gave you. So it depends. Are you clear with that? Most of the time, they can give you the graph mentioning this is a frictional force graph. Identify the, by observing the graph, identify or mark the three types of frictional forces. They can give you any set of questions. They can mix with the unit 2 lesson of your grade 10. They can mix with the unit 4 lesson of your grade 10. They can mix with any places they can give you. It depends. Okay, because I can't tell you where it will come because not in the MCQ. It comes in your essay type question. It will come in your essay question. Marking comes in the essay type. So you have to know that very clearly. Got it? Right. Okay, now let's come to the factors affecting. What we have to come, we have to learn about the factors affecting the frictional force. So let's talk about the factors affecting frictional force. You can remember this as a equation. So when it comes to the factors affecting, especially we remember as a equation, frictional force equals to nu into r. This equation is related to your A level, but I'm asking you to remember this equation. It's easy for you to remember, okay? Because you remember these as a factors, you can remember, but if you feel it's hard to remember, then I will give you a better way to remember. This way you can remember. Frictional force is equals to nu into r. So if you take the r, what's this r? We call this R as normal reaction. We call this R as what? Normal reaction. What is this nu? Nu means you are talking about the coefficient of the friction. Especially you are talking about the surface. You're talking about the nature of the surface. So if you're talking about the nature of the surface, what are the two natures of the surface you have? One, smooth surface. Other one, you have the rough surface. So you have the smooth and the rough surface. So nature of the surface is one factor that is affecting the frictional force. The normal reaction is affecting the frictional force. So first, there are people who doesn't know what is normal reaction. I will explain you what is normal reaction. So you have to understand. Remember, if any of these factors increases, frictional force will be increasing. So let me explain you about the normal reaction. So first remember the normal reaction. So let me explain you because it's important. whatever the physics lesson you take, the normal reaction is involved, especially in your unit 15 of your grade 10, unit grade 11 also you have the normal reaction. So you should know the normal reaction because it's important. Okay, right, look here. So what's normal reaction? So let's say, for example, you have an object. Okay, let's say this object is 5 kilogram. So what is this weight of the object? What is the weight of the object? Weight is equals to mass into gravitational force, as we learned. So what will be the weight? We will say it's 50 Newton. So in which direction the weight of the object is acting? In which direction the weight of the object is acting, that is towards the downwards. So you know that the weight of the object is acting towards the downwards. Let's say this object is on the table. This object is on the table. So this weight is given to the table, right? This weight is given to the table. Now accordingly, think this object is hung. So when the object is hung, what do you need to understand? What do you need to understand? So when the object is hung, we learned, what do you need to understand? There will be a tension. When the object is hung, there will be a tension. There will be a weight. So when you take an object here, when you take an object, this object is not hung. You kept it on the table. Now think, why is this duster is at rest? Why is duster is at rest? So this duster is giving 5 kilogram towards the table. Table also will give a opposite force towards the object. That is, we call it as normal reaction. That we call it as what? Normal reaction. So normal reaction means the opposite force that is given by an object, that you call it as what? Normal reaction. If the object is hung, you get the opposite reaction, that you call it as the tension. If the object is not hung, that object is at rest, then remember there is a force that is acting, what do you say, that is acting opposite to the weight. That is, we call it as what? We call it as the normal reaction, or else we, in another term, we call it as perpendicular. What do we say? Perpendicular reaction is another name for the normal reaction. Are you clear with that? Are you clear with that? So why is this object is at rest? If the weight is given 50 Newton, normal reaction is also 50 Newton. So that means the resultant force is what? Zero. So when the resultant force is zero, this object is on the table. Did you understand the term normal reaction or the perpendicular reaction? Yes. Got it? Understood? So we'll see how it's affecting the frictional force. Let's understand how it's affecting the frictional force. So listen to me carefully. Now say, for example, I am increasing the mass of this object. Let's say I'm taking 10 kilogram of the object. Now what will happen to my weight? The weight will be the 100 Newton. So the normal reaction, now say for example, if the normal reaction, what can we say? Now weight is equals to tension. That is one point. Another point, we know weight is equals to the normal reaction. Okay, so if the normal reaction increases, now think, if the weight increases, normal reaction increases. So you know that if the weight increases, normal reaction increases. In the sense, what can you say about the frictional force? The frictional force also will be increasing. Did you understand? Clear with that? Now say if I am asking a question from you, let's say you have two objects. Let's say one object with the 5 kilogram, another object is with 100 kilogram. Now tell me, in which object the frictional force will be high? In which object will be the frictional force is high? Is it in the 5 kilogram? Is it in the 100 kilogram? Where will be the normal reaction will be high, frictional force will be high, weight will be high. Where will it be? In the option 2. In the option 2, it will be high. Why? When the mass is high, the weight will be high. If the weight is high, the normal reaction also will be high. If the normal reaction is high, the frictional force also will be high. So that's what I said you, frictional force is depending on what? It is depending on the normal reaction. Now come to the nature of the surface. So if you are coming to the nature of the surface, what are the two nature of the surface? One, you have the smooth surface, other one you have the rough surface. So in the smooth surface, the no what can you say? Smooth surface, you can move the object very fast. So which means the friction is very less in the smooth surface. If it is in the rough surface, the friction will be very high. Do you understand the difference? So you need to understand in situation wise the friction will increase, friction will decrease. Okay, now come, what are the places we can reduce the friction? What are the places we can reduce the friction? So if I like to reduce the friction, can you tell me some places we reduce the friction, especially when we are playing carom? You use what? Boric powder. Use the boric powder to reduce the friction in the board you are using. Then you are using grease, oil to reduce the friction to open the door, open the key or whatever it is. You're using a ball bearing to reduce the friction. So what else you can say? Now think why we need to increase the friction, especially to walk, to run. Then where do we increase friction? Especially the footballers, they wear the spike shoes to increase the friction. Then what else we can say? You use what do you say? Like in the tires, you have the grooves in the tires to increase the friction. In your boots, you have the what do you say? The friction has to be increased. Why? If it is smooth, you will slip and you will fall. So make sure there are situation you have to increase the friction, you have to decrease the friction. So what are the advantages of frictional force? Walking, swimming, running, these are the advantages. So what is the disadvantages of frictional force? What is the disadvantage? Now think, when you rub your hand, what are you producing? So you remember the frictional force is created when two surfaces in contact with each other. So when two surfaces in contact with each other, they create what? What do they create? They create frictional force. So when you have the contact with the two surface for a long time, you produce heat. So one of the disadvantage of the frictional force is what? You produce heat. So that's about the unit 5. Are you clear with that? Are you clear with that? Yes. Any doubts? Any doubts with that? Are you clear? Okay, right. So let's stop from here and I will update you with the other lessons on another day. So we will slowly complete each and every lesson. At least we'll target 2 lessons per day. I will update you maybe every Thursdays we might be having the session. I will update you about it. It depends on my time, okay? So I will definitely update you earlier with the chemistry and biology also. But get ready for the Islam, get ready for the health if you feel like you wanted to revise the lesson and let your friends know about it. So I hopefully stay in the group. I will update you everything. If there's any doubt, you can contact me anytime. So then have a good day. Take care. I know you're very tired. So take care. Good night. See you on another day. Have a good day, guys. We are done with the lesson. If we are trying to start with a new lesson, it will go beyond level. Static energy produced by rubbing two objects. Yeah, static electricity. So it is a frictional force. It's like this. It's connection of the frictional force, electricity, and everything together. You will study that in A levels. But in this situation, you don't have. In this syllabus, you don't have that. But that's a good idea. You brought it up, Sarah. Right, I will update you the recordings and everything, and have a good day. Take care. See you guys.